Hello, good morning students. My name is Oliver Cases, together with Angel Fitzibondon, and we're here to discuss where does mathematics came from in Egypt and Babylonian. Does anybody knows about the mathematics of these two countries? Okay, so let's proceed to the discussion. First, we have the table of contents to the topics that we will discuss. First is introduction, ancient Egypt, Egyptian mathematical achievements, ancient Babylonian number system, and mathematical achievements of ancient Babylonian. So here the introduction. The story of mathematics begins not with abstract theories, but with the practical needs of ancient civilizations. Around 3000 BC, both ancient Egypt and Mesopotamia, specifically Babylonia, saw the rise of sophisticated societies that required complex systems for managing resources, building structures, and tracking time. Egyptian mathematics developed alongside the impressive architecture and engineering, utilizing a system of hieroglyphics for numbers and devising practical methods for calculating area, volume, and fractions. Meanwhile, the Babylonians pioneered in astronomy and developed an advanced base 60 number system, still evident in our modern measurements of time and angles. While these ancient civilizations didn't have the abstract concept of modern mathematics, the practical applications laid the foundation for the future developments, ultimately leading to the sophisticated mathematics we know today. So let's talk about the ancient Egypt, wherein ancient Egypt was conquered by Alexander the Great of Greece in 382 BCE and became a Roman Empire under Cleopatra in 30 BC. The ancient Egypt society was built around the Nile River and provided a fertile land for agriculture. The actual land after flooded of soil created needs for the calculation of measurements, such as measurements of land and crops, track time and astronomy, and exchange rates and goods. Egyptian does not allow others to study mathematics, but the one who only allowed to study is the priestly class, the Pharaoh himself. There are two mathematicians in ancient Egypt that we will discuss. First is Hames. Hames is one of the mathematicians who wrote the rhymed mathematical papyrus, the famous mathematical text of ancient Egypt. The papyrus contains 84 to 87 mathematical problems and solutions such as arithmetic, algebraic expression, geometry, and so on. The second is Djoser. Djoser is an architect and a mathematician who designed the Pyramid of Giza, one of the earliest pyramids of Egypt. His work demonstrates a strong understanding of Egyptian geometry and architecture. So this is the picture of the Pyramid of Djoser. It's not like the same of the Great Pyramid of Giza, because Great Pyramid of Giza is taller than this. So ancient Egypt developed a decimal-based system, wherein in this system is a distinct symbol to represent a number, such as 1 to 9 represents a vertical line, 10 to 90 represents a subfield bone, 100 to 900 represents a snare or coil of rope, 1000 to 9000 represents a lotus or tulip, 10,000 to 9,000 represents a finger, 100,000 to 900,000 represents a fish, and 1 million to 9 million represents as a person. Here are some pictures of their mathematical developed decimal-based system. Here, this is the Egyptian numeral hieroglyphics. In ancient Egypt used hieroglyphics for mathematical notation, wherein hieroglyphics is a complex system of pictorial symbols and it represents mathematical operations in concept. It also used to communicate and record mathematical ideas to make the solving of problems easier with the sharing of knowledge. We also use this hieroglyphic in religious, mythology, and historical purposes. Here are some mathematical notation for the ancient Egypt. Ancient Egypt also used Rhind papyrus and Moscow papyrus, wherein in Rhind mathematical papyrus was bought by Alexander Henry Rhind and preserved the Rhind papyrus, or so-called Ames papyrus. They used this Rhind papyrus to keep record and document some mathematical ideas and contains 84 to 87 mathematical problems and solutions, such as arithmetic, algebraic expression, and geometry, and so on that is related to mathematics. The writings they use in fine papyrus is hieratic, wherein it's a cursive type of hieroglyphics. Its dimension is 12 to 13 inches wide, and its length is 18 feet long. If you put it vertically, it's taller than the standard bus, wherein the standard bus only measures 10 to 12 feet. Moscow papyrus was bought by Vladimir Golonyshchev, and it contains 25 mathematical problems and solutions. They also use this papyrus to document some mathematical ideas and concepts. Here are the pictures of the Rhine papyrus and Moscow papyrus, wherein on the left and upper side of the PowerPoint is the Rhine papyrus, and the lower right side of the PowerPoint is the Moscow papyrus. So let's talk about their achievements, wherein they calculated the value of pi, and according to the Rhine papyrus, it is the Egyptian who calculated the value of pi. Calculated the value of pi by the Egyptian was one of their remarkable achievements, considering their lack of mathematical tools and equipment at the time. The value that they get is 3.1605, wherein the value of pi is 3.14. They are near to each other. Yes. Second one is this Great Pyramid of Giza. This pyramid is one of the 7 wonders of the ancient world, where the land of each side at the base averaging 755.75 feet, wherein it is 230 meters, and its original height being 481.4 feet, or 147 meters. So this is the pictures of the Great Pyramid of Giza and the back. You can compare the person in the pictures in the blocks of pyramids. That's pretty great. What if some of the blocks are drawn to you? Maybe you will die. Yes. So the next one is Egyptian use fractions, ratios, and proportions, solving problems in daily lives. They use this concept on solving arithmetic problems like adding, subtracting, fractions, and also in real-world problems such as dividing land, foods, and etc. In addition to that, they use this concept to combine something like calculated prices, exchange rates, and goods. They use ratios and proportions to design and build structures like pyramids. It will help them to solve real-life problems. So the last one is Egyptian mathematical achievement, developed Genesis 5 days calendar, wherein ancient Egypt developed Genesis calendars in a way that they keep on recording the movement of stars, determine when they can do agricultural activities, and much precise than their predecessor. Because of their continuous recording the movement of stars, they develop a 365 days calendar that will help them. So this is the pictures of the 365 days calendars by the ancient Egypt.
So after listening to the discussion of teacher Oliver Casas about the history of mathematics in ancient Egypt, let's now dive in ancient Babylonian. So Babylon is a tribe that lived in Mesopotamian region, located between 2 major rivers, the Euphrates and the Tigris. Mesopotamia is now known as the state of Iraq. They developed a complex system of writing and mathematics. And the Babylonians, who inhabited Mesopotamia, developed a sophisticated mathematics system that was more advanced than the Egyptian system in certain areas. Their knowledge is preserved on clay tablets, which provide extensive evidence of their mathematical practices. So, Babylonian mathematics refers to all mathematics developed by the Mesopotamians who are now Iraq from the beginning of Sumer Sumer, to the beginning of Hellenistic civilization. So this means that all mathematics that was developed during the Sumer to the beginning of Hellenistic civilization are called Babylonian mathematics. So more than 400 clay tablets have been found to provide the Babylonian history with excavation dating back to the 1850s. The plates were written in cuneiform writing. So what is cuneiform writing? So cuneiform writing is one of the oldest form of writing known, and cuneiform means wedge shape because people wrote it using a reed stylus cut to make a wedge shape mark on clay tablet. And here we have two tablets named Plimpton 322 tablet and the YBC 7289. So the Plimpton 322 tablet is a Babylonian clay tablet notable as containing an example of Babylonian mathematics. It was named after its owner George Arthur Plimpton, a New York publisher. And here we have the YBC 7289. YBC 7289 is a Babylonian clay tablet notable for containing an accurate sexagesimal approximation to the square root of 2, the length of the diagonal of a unit square. And here we have a Babylonian mathematician. His name is Kidinu. So Kidinu is a Babylonian astronomer and mathematician. He is responsible for System B, a Babylonian theory that described the speed of the moon's motion around the zodiac as increasingly gradually and then decreasing gradually in the course of a month following a regular sawtooth pattern. Now let's talk about the Babylonian number system. So, the Babylonian number system used a sexagesimal base 60 number. This allowed for more precise calculations and fractions. So, Babylonians used two symbols in their Babylonian number system or the sexagesimal system. So, this stick 1 is represents 1 and the arrow represents 10. So, small numbers are represented much like the Egyptian system. So, example, we have here number 23. We just need two arrows, which is 10 plus 10, and then 3 sticks, which is 1 plus 1 plus 1. And then it would be equal to 23. But when it comes to a larger number, there's a computation to get the precise or like the exact amount of that number, and it is based from the 60 power or base 60, and then you raise it into powers. Let us now talk about the mathematical achievements of the Babylonian. We have arithmetic, algebra, geometry, and astronomy. So, in the field of arithmetic, the Babylonians were proficient in basic arithmetic operations like addition, subtraction, multiplication, and division. They also developed methods for calculating square roots and cube roots. When it comes to algebra, Babylonian mathematicians were able to solve quadratic equations, cubic equations, and even equations of higher orders. They used tables and algorithms to solve complex problems, demonstrating their advanced understanding of algebraic concepts. Now let's take a look at the geometry. So the Babylonians made significant contributions to geometry, including the calculation of the circumference of a circle, the area of a circle, and the volume of a cylinder. They also had a good understanding of the Pythagorean theorem, even before Pythagoras himself. And lastly, in the field of astronomy, the Babylonians were keen observers of the night sky and developed a sophisticated system for tracking the movements of celestial bodies. They were able to predict an eclipse and other celestial events with a high degree of accuracy. So in the image is a clay tablet wherein it was engraved there the Babylonian observations of the Halley's comet.
We prepared some videos that talks about the ancient Egypt and their mathematics. So let's watch this.
How did maths go from this to this? I'm sure you can relate. When you first started learning maths, it was simple, but as the years progressed, it became more and more complex. Well, maths was not always like this. Just like the world around us, it constantly evolved over time with increasing contributions. This begs the question, what was early maths like? Why did people use it, and how did it evolve? Well, that's what we're going to cover in this series on the history of mathematics. Welcome to Shrouded Science, where we explore the science and maths of the world around us. As a general rule in history, the further back you look, the more and more scarce information becomes. The earliest evidence for mathematics is prehistoric, predating the existence of any form of paper. The Ishango bone, found in Central Africa, is believed to be dated over 20,000 years ago. This bone depicts what we believe to be a tally counting system. Clearly, our prehistoric ancestors developed the need to quantify amounts. However, this is not quite mathematics as we know it, and is more so just counting. We need to fast forward a little to find some more concrete evidence of the use of mathematics. The ancient Mesopotamian and Egyptian civilizations demonstrate compelling evidence for early development and documentation of mathematics. Through the use of papyri and tablets, these civilizations were able to transfer knowledge through communities and pass it down through time. This was crucial in the evolution of knowledge. Here, more complex uses of mathematics were developed beyond just counting. Mesopotamia is a historical region situated in the Tigris-Euphrates river system, and occupied the area that is now home to modern-day Iraq, Kuwait, as well as Turkey, Iran, and Syria. Through tablets discovered from the Mesopotamian civilizations, we are able to see knowledge slowly accumulated over time. In the region Sumer, around 2700 BCE, we see tablets show a multiplication table. With 3 columns, the first 2 are thought to represent distances, which when multiplied produce the final column, which is the corresponding area. Moving forward in time to around 1800 BCE, during the tenure of the Babylonian Empire, we see clay tablets that are believed to be lessons for how to calculate the area of different geometric shapes. The area of a trapezium was calculated to be the average of the bases multiplied by the average of the sides. And the area of a circle was calculated using pi equals 3. In fact, in 1750 BCE, during the reign of Hammurabi the Great and a whopping 1,000 years before Pythagoras, we see a table containing integer solutions to a squared plus b squared equals c squared. The exact purpose is debated, but it could be used for construction. Turning our attention across the Red Sea, in the Egyptian kingdom we see functional uses of mathematics for the purposes of administration. Depicted in the wall painting in the tomb of Mena, we see a scribe who was in charge of a great degree of reporting. Determining the size of fields, estimating crop yields in order to calculate taxes, and reporting this to the pharaoh, primitive mathematics was at the core of Egyptian civilization. From Egypt, we find 2 key texts, pivotal in our understanding of the history of mathematics. These are the Moscow and Rhind papyrus, named on their discovery and not their content. They deal with concepts of linear equations and geometry. Linear equations were used to solve issues such as the distribution of food. How do you divide 100 loaves of bread to 30 people? Or more complicated, how much flour does a community of 100 people require? Geometry was once again used to find the area of a circle, except, unlike previous estimates of pi equals 3, these texts estimate pi to be 3.16, impressively close to its true value. The Moscow papyrus shows formulas for the calculation of the volume of 3D objects such as pyramids and the surface area of a hemisphere. Mathematics is constantly evolving. The ancient history highlights the progress from simply counting numbers to the development of geometry and equations. However, this is merely the beginning in the history of mathematics. Next we will...
That's all. That's all, children, and thank you for listening to our discussion, and we hope that you learned something from us.